Hello.
Yeah, sorry. Say,
Yeah. Yesterday I talked about the Discord. Can I share my screen?
oh,
Uh,
you didn't get it set up yet.
no, I set up. I registered, but where to log in, I don't know. Can you suggest me?
You used the link that was provided yesterday?
No, no. I will present my screen. Can you see there?
Yeah, sure. Present it.
Hello.
Yeah, sorry. Say,
Yeah. Yesterday I talked. Here I have to click on create my own.
oh, you didn't get it set up yet.
No, I set up. I registered, but where to
There
log
was a
in, I
link
don't know.
provided.
Can
Wait,
you
I'm
suggest?
sharing it. You used the link that was provided
Yesterday
yesterday?
that link was not working. That's why I
No,
created
no.
on my own. I will present my screen. Can you see there?
Yeah, sure. Present it.
Hello. These screens came after I have registered my account.
Yeah, I understand that. Just give me a minute. I'm sharing you the.
Okay.
I've shared a link in the chat box. You try using that. Shobit, are you trying?
Yes, I'm trying.
So we'll be waiting for just 1 more minute to see if someone else. Then we'll begin. Okay, so yesterday you guys had a session of illustration on embedded system, right? And could someone brief what did you get to learn yesterday? Guys, anyone? No one? Ye- Okay. Achha, you understood the difference between microprocessors and microcontrollers yesterday?
Yes, Bhaiya.
Okay, so could someone differentiate that? At least one difference. What do you understand with? No one? Okay, not an issue. Fine. So before getting into today, I'm just recapitulating this. See, a processor is any basic system, a chip that you have that processes instructions. While you use anything on your computer or any embedded system device, you're processing some instructions within it. So it has a control unit register, and it is simply processing those data and instructions. And how your controller is different from it is it has memory with it, some peripherals like analog to digital converter, and so on. Uh, is my slide visible to all? The differences between microcontroller and
Yes,
microprocessor?
yeah, it's visible.
Okay. So you can see processor is a standalone chip and all RAM, ROM, IO devices are separate. Whereas in microcontroller, it has a RAM, ROM as memory, and some modern controllers, it also has RC oscillators for clocking, and then some IO, some external peripherals like analog to digital converter, and so on. And processors are dedicated processors, exactly. Means they have very high processing power and meant to run for real time processing. Whereas microcontrollers are more like application specific. What application you are dealing with?
Means, can we tell that a microprocessor can perform many programs, whereas microcontrollers can perform only special, means some type of programs. Suppose
Yeah, the program they are programmed to do that for
yes,
the
yes,
application that it is devised to do.
specified program.
Yes, exactly. So it is mainly meant to make some systems like application specific systems. That is how. And overall, all these are computation based devices. Just give me a moment. Okay. So the processors and controllers that we'll be dealing with will be basically on these. Uh, just a minute. What is the issue with presentation? Is the presentation visible now? Guys?
Yes. Yes.
Okay. So you can see the first one is an Intel iCore processor, i7. The second one is Atmega 328P. Can you recall anything with this? Where did you see this? Anyone?
The difference page is visible only.
Okay, you're freeze to it.
Yes. 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 Now change.
Just a minute, I'm making it complete presentation. Now visible?
Yes. Yes.
Okay. So you can see the first one is a Intel iCore processor. The second we have over here are Atmega 328P chips in 2 packages of it. So can you recall anything about these? Did you see this anywhere?
Yeah, in the Arduino board.
Exactly. So that was a development board, and this is the microcontroller in it that was used. And this last one that we have is a SoC design. So you know what is microprocessor, you know what is microcontroller. So what is SoC? SoC is basically a complex circuit made with the same thing, and it is also fabricated as a chip. As you can see my pointer, right? So there's a black color ESP8266 kept. Guys, you can see the
Yes. Yes.
8266 SMD chip where I'm pointing.
Yes.
Yeah, so this is the basic microcontroller plus the Wi-Fi chip integrated. And this is the Wi-Fi module. If any one of you have used NodeMCU or do you have a NodeMCU, you must have seen this. This IC is mounted on the chip. And this silver thing is what contains the SoC. And this is the internals of it. You can see there's a ESP32 written over here. So in case of ESP32 boards, that chip is mounted, and in 8266, this 8266 chip is kept here. And this WIN band is the memory extension of it. And with some oscillators, this SoC is designed for IoT applications. And it can also work with many embedded system applications, but it has a Wi-Fi, so it will be more better if you use it. It's mainly meant for AI and IoT applications. So beginning with IoT. So would anyone like to, did you guys hear anything about IoT before? Would anyone like to say what you understand about IoT? Anyone, you can raise your hand if you feel any. Anyone? Just a briefing. No one will be judged. Nothing about being right or wrong. Anyone, you can raise your hand. Okay, Anubhav, you can say.
It's basically we can control many things. Means suppose we have a cloud in which we can store data, then with which we can control many things. Suppose we give any data to the cloud, then and connect many devices to that specific cloud, then we can perform many things by using that. Means our sensor or anything by
Okay,
uploading
not bad.
data in that cloud.
Yeah, to an extent here, right? Anyone else? No one will be judged. Come on.
It's basically intelligence connectivity of physical devices.
Closer. Okay. So what Anubhav said was right, and again, this was also correct. IoT is basically interconnectivity of devices, and mainly electronic devices based on embedded systems only. And they are connect. It's not necessary that they'll be connected only over Wi-Fi or any wireless networks. It could also be any LAN network or UART network, even through USB drives. But as it has evolved, it mainly deals with wireless connections these days. So it is about interconnectivity. And then we'll be coming to the four main pillars of IoT. So these are the basic building blocks that all IoT devices use. So the first one is sensors and actuators, then processor, then network and protocol, then cloud and data analysis. So what do you understand by sensors and actuators? Anyone again?
It means, for example, temperature sensor or anything which helps us to sense that things, sensors. Actuators, I don't know actually.
Sorry, actuator?
Actuators, I don't know.
So
Okay.
basically, sensor like takes any response from the environment, like any kind of temperature, pressure, humidity, or anything, and convert into electrical signals in the form of voltage. And actuators convert the electrical signals provided to them into some kind of mechanical like action. Like it can be the movement of an arm or a movement of a wheel or anything such. Anything you can.
Very well said. You guys understand what is a transducer? No one?
Yeah.
Yes, yes.
Yeah, say what. Would you like to give a line of briefing on it? Transducer?
I think transducer is the one which actually I confused. Transducer is the one which converts the physical signal into like electrical signal, right?
Yeah. See, transducer is basically anything that converts one form of energy into another. And since we are dealing with electronic devices, so transducer, there are many types of transducer. So a transducer basically forms the sensing element of a sensor, the main element that changes, and it, like you said, it converts the sensation into electrical parameters, and then by some signal processing, signal conditioning, it is calibrated, and then you get the sensor output. And the actuators are basically output devices that actuate, and it's not only mechanical actuation, it can also be electromechanical or light actuations, many types of actuators. And processors, as you had seen yesterday, it is a main device that takes data from sensors and actuators, collect it, and then it forwards it further via different network protocols. So, would anyone like to give an example of IoT network protocol? IoT network only, any network? You have been told about some earlier, right?
TCP/IP,
Yeah, TCP/IP. Anything else?
OSI,
OSI. Sorry.
UART, UART.
Yeah, UART is, but as it has evolved nowadays, UART isn't considered that much. But yes, not bad. Anything else very common that you use daily?
Bluetooth.
Yeah, Bluetooth, Wi-Fi. So these are basically TCP/IP is not a network. TCP/IP is a protocol that is followed by the network, as you said. So networks are basically Wi-Fi, Bluetooth, and other interconnective networks, and then it is processed over different protocols. So protocols can be TCP/IP. Then again, TCP/IP is further classified like into protocols like HTTP, MQTT. We'll be seeing that further. And then this is put forward to a cloud. Now, what is a cloud? Anyone? You must have heard, na? At least you can give an example of a cloud. any cloud that you use daily? Come on, guys, anyone? At least one. Yeah, Amazon Web Services Cloud, definitely. Anything else that you use daily? AWS is a common example, right? One of the largest. You guys don't use Google Drive? That also has a cloud. Okay. So cloud is basically a memory storage device which is hosted over network. And then there are far more advanced clouds that has data analysis also on it. And then, so how the whole process goes on is, you can see the sensor senses, it gives all the data to the processor on the basis of how it is programmed. And then over a network protocol, it proceeds it and forwards it to the cloud. And then it can be retrieved back for any actuation purpose. Like the cloud will again give it back to the network, over the network to the processor, and then actuators can be enabled on the basis of it. So any doubts regarding this? And it is not always like they are always followed in this sequence only. It depends on what type of network and program you are making. The architecture is made on that way. Any doubts on this?
No, clear.
All clear? Okay. So moving to next, we have applications. So no doubt IoT is highly applicable in consumer electronics. In everyday example you have seen. Then healthcare also, corporates, automation. Any automation example that you guys would like to give? Nothing?
Smartphone.
Yeah, smartphone. In what way? What in a smartphone shows you IoT application? At least one feature. Nothing. You guys have played games. You have used those motion sensor games, na? Gyroscopic. You turn your phone around, and then you have played PUBG at least.
Yeah.
So what happens there? Gyroscopes and all are used to sense, and then accordingly data is processed over the cloud. And some examples can also be the light sensor over there, where it senses the light intensity and manages the screen. And then aerospace also in networks like GPS, examples like GPS. Then in agriculture, I think agriculture is very common these days for smart applications. Could someone state an example of agriculture where IoT is implemented?
Smart irrigation systems.
Yes. How?
Depending upon the water moisture or sensing the nutrients in the soil, we can make changes in the water level and all.
Definitely. So what you actually do in that type of system is you keep a moisture sensor in the soil, then you also check the content level. And even in modern days, people are also using things like image processing, and then retrieving the data. And according to that, the actuations are made over the cloud. And of course, smart irrigation, you can even do your farming and irrigation over the cloud. You can sit at your home and you can put a camera at your field. You can sense things over there. And then you can, like, suppose you feel that there's a need for spraying water or fertilizers, you can actuate it from distance only. Maybe from your web server, web browser, or dedicated applications. And then definitely defense, networking, automobile industry all use IoT. And this is the same thing, grid and all. So, as I said earlier, we'll be mainly focusing on IoT using Node MCU and ESP32 if you guys want to. That's the issue here. So, does anyone of you has a Node MCU right now with yourself? Or maybe you're using?
Yes, sir.
Okay. So, you're aware about all the features of it? Okay, not an issue. So, this is basically a 36-pin IoT microcontroller based device having a feature of Wi-Fi. So obviously it is a low cost device with Wi-Fi integrated. Someone wants to say something? Okay, not an issue. Coming to the specifications, it works at 3.3 volts and operating GPIO pin operates at 12 milliampere. And as I said, total number of pins are 22 plus 8, and few more 6 pins are there which are not exactly connected. They are used for memory processing units and all. So you can see all numberings over here are done in GPIO, GPIO 5, 16. And then there is something like D0, D1, D2. It's all visible to you guys, no? You can see D1, D2 written where I'm pointing.
Yes.
So this is the board numbering that is used by the library. And these GPIO pin numbering is what the connections are made through this SoC chip, this Wi-Fi SoC chip, as per the microcontroller. So that is how, so while using GPIO, you simply mention the number. And then if the library is well optimized and programmed, you can also use D0, D1. And you can see you have a 3.3V pin over here. So this is how you power this if you are powering without any USB cable and all. And for connecting it to the system, it uses a normal USB type A. Yeah, the normal micro USB type A that you use for your phone. And then it has few connectivity and data transfer protocols used in it. You can see MOSI written over here, CS. So you know what is master slave and concept? Anyone knows about it? Master slave concepts and all?
It is about nodes, right?
Sorry?
Nodes.
Notes. What notes?
Like in GitHub, there is master slave concept, Kubernetes, that type of concept, right?
No, not exactly nodes. It's more like a device is hosting and it's giving a command, and other device is also following the same command. So over these, there are basic interfacing protocols that is followed. You must have heard protocols like UART, then SPI, serial peripheral interface. If you haven't, just be patient. We'll be doing it in further lectures. So they need some interfacing pins. Like SPI is basically a 6-pin. So 6-pin interface. So MOSI, CS, clock maintenance and all are done using these pins. So that is how it works. And then the clock frequency used is 80 megahertz by this. So you can understand the frequency is 80 megahertz. So you can determine the processing speed with this. So it will be
what is this 40, 26, 24?
That is actually the internal. See, this if in case of you did Arduino Uno yesterday, right? You saw that silver color cap in it that was pointed crystal oscillator.
Yeah.
So it had an external oscillator. This board doesn't has any external oscillator. It has internal RC oscillators, that is resistance capacitance oscillators, which is internally divided into 40, 26, and 24 megahertz. So if you add up all it, that will give you 80, isn't it?
Yeah.
And there are even programming methods by which you can reduce the clock or increase the clock frequency to manage your processing speed. So,
Okay.
so
So
anyone wants?
we can increase this clock frequency if you want. Like,
Yeah, you can. There are programming methods. You need to know a bit of embedded C for that.
okay.
So this thing can be used to calculate processing speed also, as I said. 1 minute. So if you have to calculate processing speed, why am I not getting the interface? So the processing speed over here will frequency is 1 upon time, you know. So you just have to put it 1 upon 80. अरे यार क्या हो गया इसको? And mega means 10 to the power 6, right? So if you convert for speed, it will be 1 upon 80 and 10 to the power minus 6 because it comes to the numerator. So what is 10 to the power minus 6? Microseconds, right?
Microsecond, yes.
Yeah, so it will be 1 upon 80 into 10 to the power minus 6, that will be microseconds. So 1 upon 80 microseconds basically. So that will be around 0.125 something microseconds. So this is how per instruction of this microcontroller will be executed. So you can imagine how fast it will be. And it is a 32-bit RISC architecture following microcontroller. And ADC bits are 10 bits. You know what are ADC bits? You know what is analog to digital conversion? Ever heard about? So this 10-bit basically determines at what rate the data is being sampled for the resolution. So while digital data is like in binary. It is either you get the 100% of the sensation or 0. So 1 or 0, isn't it? But in analog, what you get is a range of data. So this range, what is the smallest sensation that you can get? What is the smallest electric current that is received? So it is determined by this ADC bits 10. So it goes like 2 to the power 10. So you get a range of 256 samples. So it is 0 to 255. You all understand this calculation? Anyone who wants me to show it? You understanding how 0 to 255 range?
Yeah.
Okay. In case anyone wants to know, I can show it. Just let me know. And then it has a flash memory of 4 MB. How much was the memory for your microcontroller that you used yesterday? The Arduino Uno?
32 KB.
Yeah, exactly, 32 KB. And this is 4 MB. Anyone knows why 4 MB? Then why do we need so much memory over here? Okay, you guys executed a command yesterday, a program yesterday, no? On LED and ultrasonic.
Yes.
How much line was it? Maximum 16, 20, 25 lines? But over here, since we are using larger libraries, running protocols of HTTP, MQTT, so your program will go to like 100 lines, 120 lines. So instructions at time that need to be stored in the memory will be much more. You can imagine that. And then it also has a 64 KB RAM, basically SRAM and DRAM. You know what is SRAM, static RAM, dynamic RAM? What is RAM, first of all? Anyone?
Random access memory, basically all the we can access at equal time interval.
Yeah, runtime memory of the device actually. So static RAM is basically that is when the device is initiated and at the starting point, it is more of a hardware required RAM, and it stores at once, and that data remains constant, while dynamic RAM data keeps changing as per the processes that is going on over there. So it is again divided into static and dynamic RAMs. And I've told you about the voltage 3.3 volts. This is the voltage regulator. This isn't very much important for you unless you use the board exactly. And then we have the UART to USB converter. Okay, I'm showing this to you. You can see this SILAB CP21102. You can see this thing over here, this chip.
Yeah. It's the voltage regulator.
It's not a voltage regulator. It's a UART to USB converter.
Okay.
See, these microcontrollers mainly work in at a different frequency, right? If you are converting, like you're connecting it to your computer to program, so you need a synchronization. You need a USB data bits conversion to the UART protocol that is being followed while conversion.
Okay.
So that is why this IC is used. And if you use it, if you connect your board ever, you will also need to install the library of it, the device driver actually. And then we have ESP32. This is a more advanced board in comparison to that. It's not very much also. The main advantages that you get over here is that board was a single core board, and this is a dual core. Anyone knows what these processor cores do? You guys have studied about microcontrollers and microprocessors earlier, how instructions are executed.
Yes.
Okay. So there is instructions per unit time. So like I earlier said, execution of one instruction will take nearly 0.125 microseconds over here.
Yeah.
So in dual core, it will be like parallelly 2 instructions will go in the same runtime. So it is much more faster than that.
Like it will be like parallel execution.
Yeah, exactly. 2 processes at a time. And 1 minute. Where's this board? Yeah. If you can see over here in Node MCU, it had only ADC 0. Can you see any other ADC pins over here? So it has only 1 pin for analog sensation. Like if you want to connect a analog sensor to measure, you can only connect 1. But over here you have in ESP32, you have 8 ADCs if you check. So you can connect much more, and then again you have, in this you have the oscillation ranging much more. The frequency can go up to 240 megahertz. And you had seen the silver chip, na? It has internal dedicated crystal oscillators also, rather than only RC ones. And then again 36 pins, the same 3 volt voltage that it takes. Yeah, here also you have a 3v3, 3.3 volt, and then ground, and this V-in. Anyone knows why this V-in is used? Anyone? It is mainly used to power the board.
Yeah.
And what is the difference between this V-in and 3v3? You could also power from 3v3. See, it is always beneficial to power from V-in because it has a safe capacitor connected internally that cancels the voice and makes it safer for the board. So it is always recommended to use V-in more. And 3v3, you can power other sensors that you are using when you need VCC to be connected. So it also has a 4 MB memory, but RAM is much more as compared to that. You can see it is 520, and rest everything is same. And one extra feature that it has is in ESP8266, you only had a Wi-Fi connection. Here it also has a Bluetooth and BLE. You know what is BLE? Bluetooth low energy device? Anyone?
Yeah,
is the
basically in the 4.0 version and later has a low energy.
Yeah,
Great.
it was introduced after 4.0 only. But how is it different from normal Bluetooth? See, it is low energy because over here the device runs only when, like, suppose, take an example of home automation. You have your mobile phone, you're controlling your lights. So when you're controlling it, you're via Bluetooth is always connected. Some instruction is being pinged, it is always checking how much data is coming and going. So it is always active. But in case of BLE, it only activates when a data is being given. Like when you switch, only then the Bluetooth will be used. So comparative, and rest of the time it goes into low power mode itself. The clock frequency is reduced and kept. So that is how it uses much less power. And as I told you, it has extra ADC pins and dual core. You can go through it. And one problem in this using this board is you need an extra capacitor to be connected. Or otherwise, while programming it, you can program your Node MCU simply, but while programming this board, when uploading the program, you have to press the boot button for a few seconds when it is uploading, because there is some manufacturing issue in it, which you can also overcome by connecting the enable pin with the capacitor. So that will reduce that issue. We are done with this. So I had given some installations to be done, right? This package to be installed in your Arduino Uno. So Arduino IDE actually. So did you guys install it? Are all ready with that package?
Yes.
Okay. In case someone is facing an issue, you can mention that in the chat or Discord channel. So we'll do this program later. So coming to networking. So I've mentioned earlier, we'll be using more of Wi-Fi networks over here. So how are devices actually connected? See, this network will be nothing more. You guys have used Wi-Fi networks in hostel also. At your home also, you must be using Wi-Fi. Even your phone can host a Wi-Fi network. So this is basically getting connected. So what is actually happening? You have seen a Wi-Fi router at home? Or in hostel also we have in Keet. So what is that actually? That is the access point which is hosting the network. Okay. So, and how are these working? It is working over IP addresses. Like someone said, the IP TCP protocol. So what happens in IP TCPs? There are multiple protocols within it also, and these work on IP addresses. And there are two IP versions that is mainly used: IPv4 and IPv6. IPv6 is much more advanced and used for high-level computing, and it is IPv4 is 32-bit IP address. You can see there are 172.16254. So anyone knows what is this 172? You can see it's written below only. It's a 8-bit conversion of it. So each between the dot is actually a decimal number, which is further converted into 8 bits. So you can see there are 4 dot separated numbers. So 4 into 8, it becomes total 32-bit IP. So this is how it gets connected over the IP addresses, and data is processed in digital forms. Then I told you we have different networks: BLE, Bluetooth, GSM. Okay. So now coming to the protocols under IPTCP. So basically what comes over there is unpacked data protocol and then these one. So in fact we have HTTP and MQTT. So you guys know what are server client concepts? Anyone, what is a server? Would you like to elaborate? Any guesses? No attempts? Anyone can raise his hand or say about it. At least a line. You use a server. Even we have connected you through a Discord server. So what is a server? Okay. So no attempts. Not an issue. So basically, server is a device which is hosted over cloud, and it is something waiting for a request to be received. So in case of IoT, what your server is any device that you're using, like your smartphones, your laptop, even you're using your browser. So your browser actually becomes a client and it is connecting to other servers. Like when you're using Google, Google has a server of its own. So what you're doing is you're sending, see how client server concept actually works. I'm using the jam to show you. Yeah, so this is how it actually works. You can see the first block is a client, and second, forgive me for my writing. I don't have a stylus over here right now, so I'm using my finger. So what actually happens is the client keeps sending requests, and like you are the client. You are sending a request for a search engine. You want to search something like anything you type, like what is my location, so it goes to the server and then server responds to it. So what you get back is response. Is my jam visible to all? Anyone?
Yes, sir. Yes, sir.
Yeah. So what you get back from the server is response, and then there are multiple types of request and response that we will be dealing while programming. So done with this. And then we have multiple classes like Wi-Fi class, client class. Wi-Fi class is used when you are just enabling the Wi-Fi and using. It is basically, you guys had installed the package, right? So while programming, you will see we'll use this Wi-Fi ESP8266 Wi-Fi.h. So this is basically a library within the IDE that you have installed. So that contains these classes and objects that you'll be calling in your program. So client is when you'll be connecting, you'll have something like client dot something. We'll see to it. And then we have these Wi-Fi classes inside the Wi-Fi class. That is Wi-Fi.ssid, which is used to fetch the SSID. You know what is SSID? All use a Wi-Fi network these days. You have seen it while connecting your hotspot. Yeah, the name of the device that you're connecting. Actually, it is oriented on the Wi-Fi device inside your system, that SoC chip. So you can give the network a SSID name. And what is RSSI? Would anyone like to try this? The full form at least? Okay. So RSSI is
Reverse
basically...
of SSI.
Sorry?
Reverse of SSI.
What is SSI then? See, RSSI stands for basically receives signal strength intensity. So you can see it returns the signal strength as it is written over here. Like you're connecting your phone to a hotspot. So there is a range within which you can connect. So how far you are, how intense the signal you are receiving it. So it has a value of its own and you get it in terms of decibel. So if you are very far from the network, then the RSSI value obviously decreases. And if you're closer, it increases. And then we use Wi-Fi scan networks to see how many devices are available for connections. And then we have this MAC address. You guys know what is MAC address? Would anyone like to try this? MAC address?
is the unique code with which a computer or a device connects in the network.
Unique code with, then what is IP address? While connecting, generally IP is used. MAC address is the device, like you all are using a laptop right now. So every laptop has a MAC address of its own. It's an inbuilt address in the system. It can't be changed. And while connecting, you use MAC, but mainly subnet and IP are more dominant. And if you want, you can try this on your own also. You can just do this. Just a minute. Okay. You can see my command prompt. All of you have a command prompt on your Windows. Guys, you can see command prompt?
Yes.
Okay. So just type, open your command prompt and just type ipconfig. To receive a whole data, just check your wireless LAN adapter. You can see you receive a IP4 address. If you can try this in your laptop also. You see, this is IP4, therefore 32 bits again. This 1104 is one address, and then one between. And then you have a subnet mask. And each is 8 bits. So as it was shown over there, how this got to 255, this is the maximum value actually. I told you, between each dots there are decimal numbers, and they are then again 8-bit numbers when converted to binary. So how you get 255 is actually, see, since how many states do we have in binary? What are the outputs?
Two states.
Yeah,
1 and
0 and 1. So since it is 8-bit, 2 to the power 8, so that gets to 256. So it ranges from 0 to 255. So that is how it is. 255, the maximum subnet.
Last one 0. Why not? It's 255.
That is the general subnet, dedicated subnet. It is always like that. And then gateway is what you are using from the access point when you are connecting to a device. So here in my case, the gateway is given, and this subnet will be constant for everyone. I think everyone is receiving this as 255.255.255. What will be varying is the IP and gateway as per your network that you are using, isn't it? Did anyone try this? Fetching your own system's subnet?
Yeah. I've got it.
Okay. So I told you about HTTP. So coming next to MQTT. So MQTT is not, it is more a data-centric protocol actually. So like in HTTP, you have running instructions going on, searches going on, streaming going on. But in case of MQTT, it's not like always stream. It's more like there is some data to be collected and kept. So you can see over here, there is a diagram on the right. So what happens in this case is there is a MQTT broker, which is handling everything. It is a cloud-hosted broker actually. And then you have some publishers and some subscribers connected. So what is publisher over here? Publishers are basically sensors and other input data reading devices that is connected to the broker. So like you are using, for in case you can say the soil moisture sensor you use today. So it is reading a moisture level, right? So it is publishing those values to the MQTT broker. And then there are some subscribers connected. Subscribers are basically the devices which want to check, like you can take an example of weather station. What is actually happening? There are different sensors deployed, temperature sensor, humidity sensor in different locations, isn't it? So that is processed in another microcontroller or the computation-based system over there. and then it is connected to a cloud network. And these are global clouds. They're actually global clouds and local clouds we'll be seeing today only. So these values are published, and then depending upon like who wants to see, if you are subscribed to a weather station, you will be subscribing to the broker, and then broker will be sending values to you. And then there is something called topics made. So these topics will be actually what parameters you are measuring. Like for temperature, you make a topic. For humidity, you make a topic. And that was all with protocol today.
Can you repeat what's a broker?
Broker is basically like you heard about Adafruit.
Yeah.
So broker, what is Adafruit? It is a cloud hosted server, isn't it? It's basically hosting the service. So broker is the main intermediate. Adafruit over there is the main hoster that is hosting the network. And all data that you're publishing is going to that cloud over that it has, a server web page that it has. And from that, it is the intermediate thing to which the subscribers are connected and sensors too. Is it more clear now?
Yeah.
Or
Can you please tell this concept, publish or subscribe communication pattern? I'm not understanding.
okay, wait, I'll show it to you. Okay. So for example, you can say Jam is visible to all, right?
Yes.
So there is a cloud hosted service of Adafruit. Okay. And then you want to use this. So what you're doing is, suppose you want to deploy a weather station of your own. Okay. So you are using a MCU, and this MCU is again having sensors, like you have a temperature sensor, say temperature, then humidity sensor, humidity at one point, then another point there's another MCU. It is also having some sensors, say light sensors. Say you did with LDR yesterday, right? So you have LDRs, and then you make topics on Adafruit. Like you make a topic of temperature, then you make humidity, and these values you're publishing it. So now you get what is publisher?
Yes.
Okay. And then there are systems like you hosted the weather station. Now you want to deploy it to the public. Like suppose you have deployed it, I want to see. So what will I do? I will subscribe to Adafruit that I want to check these values.
Yes.
So you have subscribers, and these subscribers receive data on sending things. So now it's more clear?
Yes, it's clear.
Okay. So now Pratyay will show you more demonstrations on this. Pratyay, are you here?
Yeah, I'm here. Okay, so we have done a lot of theory. So let's move on to some hands-on trying and how to do and what is going on. So everybody, as per given in the Discord, has everybody installed two of the at least downloaded two of the softwares that I have said that the team has mentioned? Anybody? Okay, not an issue. Okay, not an issue. Okay, is my screen visible? Okay, first we will learn how to use Mosquitto. So Mosquitto, what is a Mosquitto? We have learned about MQTT. You have learned just now, Ragib has said about the brokers. So Mosquitto is nothing but a broker. It's an open source messaging broker that implements the MQTT. So let's see how we can install it and how to run a broker. It requires no hardware. Just you need to be sit on your front of your computer, laptop, wherever you are. Okay, just go and download this tool link download the two links that has been provided. One is the Mosquitto one, another is the my MQTT Explorer. MQTT Explorer is nothing but a client, and Mosquitto itself is a broker. Okay. See, we have this page of Mosquitto. So what we'll now will do is download it. So we can download directly. We have an x64 architecture of if you have your 32, you can install your 32. So do any of this too for Windows. I've already downloaded that. So let's jump into that. Downloads. Yeah, so you have seen this is a Mosquitto 2.0.8 install version of 64-bit. Let's run it. So please follow everybody. Just next install. Okay, there is an issue. Okay, let's check it once. Yeah. So what we can do is we will go to local disk C and then program files. Then you can see your Mosquitto here. Okay, so Mosquitto has several files. We will not be concentrating on where to go, where not to go. Let's first do the first step. Have everybody installed it? Are you ready? If yes, please say yes.
Installing.
Okay. If anybody has a
In case anyone is facing an issue, just raise your hand.
Yeah, you can raise your hand. There is Discord, there is chat, wherever you can.
Okay, so assuming everyone is done.
Okay, let's move on then. Okay, so what we will do is first we'll get the path of this. Getting the path is very easy from here. Then we will run a CMD with administrative privileges. Okay, you for your computer you need to be on administrative, as I'm using a virtual machine, so it is already on administrative purpose. Okay, so what we need to do is go into that location of the file. So just we need to add Mosquitto. Okay, so we are inside the Mosquitto, and we can see there are various files here. So basic setup of Mosquitto, we need to do is, as Ragib has said about the IP. So it works with TCP, right? So as it works with TCP, we need a port to be open for the connection to be alive within the subscriber and the broker, or the publisher and the broker. So let us first configure my broker. Then we will concentrate on how to do it. So to configure your broker, first you go into this Mosquitto folder. You can go to your Mosquitto folder or anywhere. Just create a file. Okay, just create a file, text document. Just name it anything you need, anything you can give, whatever. I'm naming it as config1 dot. Now this is very important. The extension should be on F. Okay, as it is a configuration file, this should be a conf. We press enter. And again enter to open the file. Okay, simple and notified. We have to give two commands. So everybody is following, right? So we have to follow two commands. That is, the first one is allow anonymous to be true, because we are not see MQTT has to be some kind of when you will run it in your real life, in real applications, you need to protect it, so that the outside world people cannot see what is going on inside your server, in your broker, and what is being published. So anybody can change, and this can create a lot of problem. But for education purpose and the first time you're using, so we will do the allow anonymous as true, because you being any anonymous person can enter into your ambing. So we have enabled that for true for now. So this is the first command. Next is we need to set up a listener. So what is a listener? Listener is that we on which port will on which host will your broker listen upon. So I am setting it to be 880. You can set it to 81883. Any TCP protocol you can go for that. Any port you can go for that. And I am using 0.0.0.0.0.0. So what is the significance of it? That means that from any IP within my network, as Mosquito is a local broker. So what we need to do is what I have done here is for any local IP on port 81880, the broker will accept a message or publish a message or we, anything, publish or subscribe. So once this is done, these two command are done, just save it and close it. Okay, so your configuration is ready. So now we need to just run our server. Okay, so for running our server, what we need to do is just type Mosquito here. We have to first, this is very important, we need to go into the directory first. So I went into the directory first, that is my program files, and then Mosquito. To know what is inside this command, just type help or version, anything. Oh shit, there is a problem with it. Okay, as you have seen already this, I'm going to exit it and we're going into my computer. Okay, same thing, not an issue. Where is my program files? Then we will go to Mosquito. Okay, so nothing, same procedure. We need to open properties, get your folder, run your CMD, run as an administrator, yeah, give administrative privileges, give a CD, go into your folder, then just type help something. So as we can see, there are various commands in with this along with the Mosquito command. As we can see, this is a C which specifies the config file just we have created. So we know the config file. Now there is a D that put the broker into the background. We will come to that afterwards. H is display this for help. Okay, that's the help one I have used. P is for the port specifying. You can specify, as I have specified the port already in the configuration file. I don't need to specify the port here. And the verbose mode is for the logging purpose. You can see every log, the detailed log here. So I will concentrate on C and V. Okay, so let me check here once. Config. Yeah. Okay, fine. Let's go to here. Mosquito. We'll go for first for V, as I need the logs of everything. Then we will go for C. See, now I have to, now where my configuration file is stored, I have to mention that. So same thing, go to your properties, get your configuration from here, then paste it here, then mention your file name, config.conf. Press enter. Okay, so there is some problem. Why? Say config1 dot. Okay. As I am already in the as I'm already inside the directory, I don't need to specify the whole path. We just need to specify the file name. If your file you are storing it somewhere else, you need to specify it. You need to specify the whole path. Okay. See. So now the log has started. As you can see, that the Mosquito is a verbose in a verbose mode with the configuration file of config1. Now the first is the Mosquito version has started. Now the configuration file has been loaded from config1.conf. Now the IPv version 4 on port 1880 has been opened. So before running all those things, before running all those things, what you need to do is first you need to go to wf.msc. Okay, this is your Windows firewall, and you need to enable this port. Why? If you don't enable this port, then how will outside connections will come? So in inbound rules, select for a new rule, port, and then next. Specify your port, that is 1880. Click on next, allow the connection, next, everything is perfect. Next, you just create a name of something else, something, give a name like MQTT with the port name, with the port ID for future references and purposes, and click on the finish. I'm not clicking because I have already, there's a running here for me. If you want to check, it is here. My 180 port is open for my MQTT connections. So before running this, you need to run this for the purpose to open this port for all the IPs in your private network to connect and configure with this. Okay. Now this is over. This is over. Okay. Now leave this for login purpose. This terminal window goes there. I am opening another CMD for this. Again, we will move to that location. CD. Okay, yeah. So now this has two. Basically, it has two functions. This is the broker. Consider this window as a broker. Now this will be another. I'm creating this two. Okay, just a minute. Mm, yeah. CD. Okay, so we are both in that directory. Okay, now this window, the upper one is the broker. Okay, that means Mosquitto is running, and the left hand side is for the clients. I'm keeping two clients, for one for publish and one for subscribe. So what is published? Now let's see the magic here. What first I will subscribe to a topic. Okay, so what is the command for that? Mosquitto sub. Okay, Mosquitto sub. I will mention my port. It is not the default port, as default port is 1883. I'm not using the 1883. I'm using 1880. So that is why I need to specify my 1880 port with my topic. Now, what is my topic? For example, today's elapsation. Okay, so I pressed enter. Nothing will come because it is waiting for the messages to come. Now we can see in the log. See in the log. See new connection from this IP. So this is what is 127.0.0.1. Can anybody say what is this? What is why this IP? What is this IP generally called? Actually, what is this called? Everybody has some point of time and has encountered with this.
Loopback IP.
What? Pardon me.
Loopback IP address.
No.
Remote
This is
host. Like
no. That is a local host because we are in the local now system, right? This is my local host. So I am hosting my server from here, and I am on my clients are also in the same IP. So why I need to write my own my own IP? Just to go for the local host because that is my local server, right? Now we have seen that now new client has been connected, and see we have here the topic. Okay, so now let's go for the subscribe by publish part. Mosquitto publish. Again, specify your port with 1880. Then your topic, on which topic you want to publish. For example, I want to publish on that topic which I am subscribed to. Then my message. For message, we need to add M. So it's very easy. For port, we need to write P. For topic, we need to write T. For message, we need to write M. Uh, okay. There is some problem here. Okay, just a minute. Just a minute. There is a server issue, I suppose. With 1880, it is not working. Okay, let's check with something else. With my, sorry, pardon me, MQTT Explorer. So this is also a client. We'll test it with a local host with my port. Okay, there is some problem with my. Let me refresh my server. There is an issue with the server, I suppose. Yeah, my server got stuck somehow. Yeah, my server got stuck somehow. Yeah. Okay, let's go for this. Oh yeah. So as you can see here from the left, from the right hand window, we have published it. Hi, the message was hi, and it got received here. That is hi. Again, if we publish the great day message, it will come. Oh shit. There is some issue with this. Yeah. I don't know what is the issue going on here. So it's a very instantaneous process. While you can publish from this side of the window, there's we are using Mosquitto Pub, that will get subscribed here. So if you go through the logs, you can see here some portion of it that see. So another one, new connection from port, same as I'm publishing from here, and now connected and see sending messages and receive publish. Now we have published, so that is why we have receiving publish to which topic elapse. The message will not be shown due to the security reasons. The message will never be shown. And as I've made the topic twice. So here is also the other one, the elapse here. Okay. So this is how you can set up your local server. Okay, now I would like for all of you to try give it a hands on to already server made server and a code. So that is why you can learn how to apply them. Okay, so I'm closing this. Just a minute to make me set up. Okay, everybody has your MQTT Explorer installed? Has anybody?
You have some doubt? You have raised your hand.
Yes, sir. Actually, I was unable to follow up with sir. So I was asking if you can slow a little bit.
Okay. Not an issue. If you want, and we can also repeat it again time, but in a different environment. We will come to that.
You have installed everything properly. No? You followed that.
Yeah, I have installed, but after the CMD was running, after running it as administrator, the codes and everything I missed.
Okay. You missed a lot. Okay, not an issue. So will I again come back to that point, or we will move on and then come back? in the later part of the.
You can tell it in the end.
Yeah, yeah, we will come to the
And
end.
Faizan, what is your issue? Same thing or?
It seemed, sir. I couldn't follow.
Okay,
Oh,
then I'm going for the again. Okay. So this is nothing but first open your command prompt. Very simple. Opening your command prompt, give the sorry, give your
Pratik, could you
address here.
increase the font size in the command prompt? Actually, is it
Oh,
properly visible to all?
okay. Yeah. I'm increasing. Yeah, is it visible to all now?
Yes, sir.
Yeah, it's now change the directory.
Yeah. So I will just copy my directory from here. And then I will give it mosquito. Okay, so I'm inside my mosquito folder in my C. So now what I need to do is run my mosquito broker. So have you all understood how to make that configuration file?
Yes, sir.
Okay. So once this is done, then now it is time for the broker part. We need to first see if we don't run the broker, how will the clients connect to the broker? So first we will run the broker. So for the broker, we have the command called mosquito, only mosquito. So let's see mosquito, and now I will type here help to see what is inside mosquito. So please everybody follow in your machine also so that you can understand what is actually going on. Okay. So see, as you can see, there are few commands with along with this mosquito command. So this is first is a C, that is to specify the broker configuration file. So what is the broker configuration file that we have just created called config1.conf. Then we have the D for the daemon for the background for this broker to continue in the background. H is for the help that I've just done. P is for the port that to listen to, but as we have, see, as it is written also that not recommended in conjunction with the C option. So as I have already prepared a configuration file, we don't need to use a config port. Then we need to then there is another command called V, that is your verbose mode. And verbose mode, what is that? Is overrides any login options, and that means you get your logs, all your logs in your command prompt only. So let's first do mosquito. We write type here V. Why V? Because we want all the logs. Then C. What is my configuration file? config1.conf. Now, why am I writing only config1.conf? Because my configuration file is inside my mosquito folder. But if you create a configuration file in some folder, some other folder, you need to specify that folder here. Means the full address. Means the full address. So as I'm inside this folder mosquitoes, then I will just hit the enter. See the log. Mosquito version 2.0.4 has started with the configuration file of config1.conf, and which is on which port my broker is listening is 1880. Okay. So this is the broker setup is complete. So how my broker is working, it is complete. Now leave this for the broker. Now we will run another CMD for the clients. Okay, the same thing. We need to run. We need to go to that directory, same directory, mosquito. As we have inside this mosquito directory, we will type here mosquito. So now see, now there are two options left. We can do the subscribe and the publish. So for publish, we will write mosquito underscore pub. For subscribe, we will write mosquito underscore sub. So first I am subscribing. So when I publish a message in the next time, we can see that here. So I am subscribing. For subscribing, what we need is my port to listen upon, which port to send to subscribe. Now another is the topic, which is very much important because on which topic we want to listen upon. So we will specify my port, that is my 1880, and my topic, that is elabs. Okay, so when I hit the enter, nothing will show because it is listening. Now in the configure, in the broker part in the log, you can see already that and see the new connection on port 1880 is open, and the client, see, this is my client side, this is my client, a subscriber or a publisher, both are clients. So a new client is connected from the same IP as of my local IP. This is my local host, and this is subscribed to elabs topic. Again, I open another command prompt and go to the same directory. Everybody is following? Is there any problem? You can stop me and ask.
So no one has doubt what is 1880 port over here. Pratyay said port so many times. What is port? No one has doubt about that? All clear? Come on, guys. If you have, you can raise your hand and ask. The class is being organized for you only. Okay, then could someone say what is port? Could someone from the audience itself say? Anyone? Aditya, you know what is port?
Roughly speaking, it's a point or gateway from where the packages come and go.
It is a gateway, a sort of gateway, not exactly gateway. See what the number that like he has specified 1880. So we had different protocols of IPTCP, right? So each different protocol has a unique identification number. So the port number specifies which protocol to use, when to access which protocol. Like if you are using HTTP or HTTPS, each has a different. So for MQTT, 1883 is generally used over global, and when for the this what you are using, Mosquitto, yeah, right. So for case of Mosquitto, while connecting to local servers, you're using 1880. So that is specifying. Otherwise, it can connect to other protocols also. So that is why he's using 1880. I hope it's clear now.
And moreover, you can create your own TCP port for running your broker. As I've already mentioned, you can open your wf.msc, that is my Windows firewall, and you will allow the inbound rules. That means I will go for new rule. I will specify that I want a port. So you can listen here, written here. I want a port that rules said that it controls the connections for TCP or UDP ports. Next, and specify my which port you want to run, and then again press enter. Something like, for example, 1890. Again, next enter. Then you will write allow my connection. Then allow. Next. You will write here your name for future references. 1990. Finish. So see. So now I have my 1880 running. I have my 1883 running, and I will also get my new port that is updated. Wait just a minute. Should come anywhere. Okay, 199. Yeah, see, MQTT 199 is also here. So basically, you can run your broker on any port. You have to keep in mind that that port is not occupied by somebody else, some other application or something. So if that port is free, and then you can run that broker in that port also. So coming back to here, we have already subscribed to my elabs topic. Now let us publish some message in elabs topic. So for publish the same thing. We need my port, on which port I need to send 1880. Again, we need to specify my topic, that is my elabs, and my message can be anything. Okay, just a minute. Problem with this. Yeah, that's a problem with this. Yeah, as you have seen that the message has already come in this public subscribe part. Yeah, so it is a bit slow. I don't know that there is some technical issues with it, with the broker. If you run in your machine, nothing will happen. This will be same fine. As you can see, I am publishing from this side and it gets subscribed on here. So you have now understood, we have now seen a very, very, very basic thing, that I have my broker clients, with the client maybe a publisher or a subscriber running on one machine. In case of real world scenarios, will not be the client, the publisher, the subscriber, and the broker will not be present in the same computer, same server. So what we can do is we can move to cloud. But before going to that, we will learn how this works. Okay, how this works with in conjunction with our Node MCU. For Node MCU, first I would like all of you to install that MQTT Explorer. All do you have the MQTT Explorer installed?
Yes, sir.
Okay.
Yes, sir.
So if you have MQTT Explorer installed in your computer, just a minute. Everybody, please open your MQTT Explorer. We will be coming to that part. Oh shit. Just a minute. Okay, so this is nothing but a cloud machine that I have borrowed from AWS. So everything is same, just my operating system is is very different from here. I suppose you cannot see here much. Anybody can tell me how to increase the size of this partition? Okay, you don't need to actually see this.
You tried Control Plus?
Yeah, that's a good way, but no, it's not working. It's not working. So you cannot see, right? It is very small, right? Okay. Let's see if we can. Mm, okay.
Can you
Appearance.
guys see it clearly? Is anyone facing issue?
If you're facing issues, you can see.
Raise your hands, those who can't see clearly. थोड़ा बड़ा करना पड़ेगा
ना। इसमें कहाँ से करो पट्टीजन पे? फुल स्क्रीन पे तो नहीं होगा, कमांड पे नहीं है। चेंज सेटिंग, इसमें तो सेटिंग का तो लॉग आ रहा है। appearance Okay, that's not a problem. Basically, I will just read out the commands. The same commands that I have already used. That is my. Wait a minute. If I change it to my window, anybody? No, let's not change it to window. Okay, the same commands. Okay, as I'm not using Ubuntu, that doesn't mean that my commands will change. The commands are same. Mosquito with V, and the configuration file is, as the file system is different for Ubuntu, this is a very different directory. Okay, yeah. So basically what has done here is I read out everything. So this is a Mosquito version. The Mosquito has just started when the port of I have used the same port 1880, but and as if you can see, just a minute, let me turn on my camera. Okay, can everybody see this little model there? So this is my Node MCU. This is my Node MCU running, and I have an LED here. This is my running LED. These are not my running LEDs. This is my running LED that is connected. This one. So we'll concentrate on that LED. So my what is my program is what is my intention here is that you all will using your MQTT Explorer you will subscribe, you will publish a message, and it is Node MCU is already been subscribed to a particular topic. I will share the topic and my IP details, and now you will type that into your MQTT Explorer, and we will see that if you type from your home in my home, that LED will glow up or not. Okay,
You guys can
so
put the video and see it, or you can use the tile mode. That will be clearer.
yeah. So before
And those who
that,
can't see these commands written well, I have posted a enlarged image in that Discord channel that you are using, so you can see the image over there also.
yeah, thank you. Okay, so now we will go for the IP, right? Mm, okay. Mm. So anybody in the group can see the IP with the port as 1880. Okay, so I've posted the IP and my port. So just follow what to do first, then you will do in your machine. First, open your MQTT Explorer. Okay, very easy. MQTT Explorer is open. You will click on New Connections. This plus little plus sign. You will type in the host as in this one, the 3.140.80.129, and the port 1880. Name it anything you want. Okay, so now what I need to do as I to understand who is logging and who is not. So just go to the advanced section. There will be something like for example, see. So there is a sys button. You need to go for that delete button, and you should delete that. Okay. So it will flood the whole server with various unnecessary informations. Go and delete it first. Okay. So first, what you need to do, I am again repeating my steps. First, the click on the little plus button. While you click on plus button, name anything you want. Just can write here elabs or something. You have to type your host. That is, host is nothing but the IP address that is provided on the Discord. I will also post it on the meet. Where is my meet? Yeah. So there is also the IP address and the port mentioned. So the host will be that IP address, and the port is 1880. As I've already created, I will not type that one. So as you can see, and leave everything else, just go to the advanced section, delete. There will be a sys like this. There will be a sys. Go and delete like this. Very simple. While you have deleted, then again come to the MQTT client ID and write your name there. Okay, write your name there. Okay. So I'm writing my own name here and go back. So I'm ready with this and just hit connect. So now I will request everyone to do this first in your own computer. If everybody is finished, please say yes or raise your hands. Finished.
Yes.
After deleting sys, what you have told?
Yeah. After deleting, just a minute, I will show you again. So you have given your host there, report there, everything is finished for that part.
Yes.
Okay. So go to the advanced and delete this sys button. Okay. Sys, delete this sys, and now in your client ID, write your name. Okay. Write your name there. Have you all written that? After writing the name, press the back option. This back option. If you have done, then press connect. If you have connected, please don't do nothing right now. Just stay connected. Okay, as I can see, Aditya Nayak has connected. Okay, and Dokania has connected. Somebody. Anybody else want to see it
One
with their
guys
hands on?
connected.
Yeah.
You'll be able to control things so from there itself. It will be fun for
Yeah,
you.
it will be very much fun for you, and after that we can also you can see how can you can even chat with your friends here also. Just log in. Okay, so now I will request Aditya Nayak to go here and write here LED state in a camel case format. That means with small L and S as capital, like this. Okay, Aditya, are you following? I'm
Yes, sir.
okay. So now just go and click here raw. Under the raw, there is a button. You click on there raw. Have you clicked?
Yes, sir.
Then right here on in any format, you can write small on or caps O and then small full caps. Okay, who has given? You have given.
Yes.
Just a minute. Just a minute. Okay. There is a problem here. Let me disconnect. Just a minute. Okay, do it again, please. Okay. This is not working like that. Aditya, are you doing it correctly?
हाँ तुम्हारा ऑन हुआ LED स्ट्रीट आया.
मैं कर रहा हूँ ना. आदित्य नहीं हो रहा है ना इसका.
अच्छा
So Aditya, are you doing it perfectly as I've said? Have you gone through raw and
Off it from your side. I try it once again, switching it on.
okay. I'm not doing anything. You can do it.
Okay, sir.
I'm disconnecting also. So do it if you can. I see you are publishing, but nothing is happening.
Yes, sir.
Because you have given a space after LED state. You have to be
No,
very much perfect. Yeah, I can see it from here. You have given a space. Please, don't give a space. LED stays state without a space, then no space after that. Yeah, see. So now the LED has turned on. With your command, you are sitting from there,
In the
and with
video.
your command,
Just pin it and
uh,
see the
yeah. So now you can Aditya. So okay, Aditya, you have given the on statement. You can also give the off. Please state the off. Give the state off. Anubhav, please, just for a minute. Let Aditya finish. Everybody, please wait. Yeah. Okay. So Aditya, you have seen, right? So now we will move to any volunteers who can try on that. Next, who wants Anubhav or Dokania? Let's go for Dokania. Dokania, give it a try.
Okay.
Yeah. See. Then yeah. See. Okay. So now who is there? Anubhav is there. Anubhav, please try. Yeah. Please turn it off. Please turn it off. Anubhav.
It's not turning.
Okay. It is not turning off.
Yeah, I'm giving space and then typing off.
No space, no space. Just press off. Just write off. OFF. Nothing else. In raw. No space. Nothing. You delete the previous on, then give it an off command. Yeah. See.
Yes.
So this is not at all a magic. From here, you are sitting there, and this is running from here. So this is actually I'm running this broker on a cloud machine. Okay, so that is basically I've made my local server in local broker, Mosquito broker as a cloud, and that's why you can communicate and connect to mine. And while I am sitting on my Wi-Fi and you are sitting on your some network, you can control my devices. That is IoT, right? That is Internet of Things. So and moreover, this is not like that topic also, and now you can do that something. Okay, everybody use your name. Okay, in your topic, write your name and state a message, any message. How you're liking this session for today? Always be at raw, so there will be no problem. Yeah. So see, everybody can see, right? Everybody on their MQTT Explorer can see. As I can also see, as Dokania has given amazing. Thank you very much. And any other? Yeah, Anubhav is saying exciting. That's fine. Then, please, Aditya, if you can. Yeah, that's right. Complicated yet great, but you need not to know what is going on right now. Just I'm showing you, just for fun, right?
And this is
Okay.
just demonstration. He's coming to the explanation.
Yeah, I'm coming to the explanation and everything. I'm coming it. Just I'm showing you how fun it is to do things. So as you can see that you everybody can communicate. Who has subscribed to here can also communicate here through here. So this is actually how MQTT broker works. We haven't gone to how to code this little node MCU to do the such things, but we have seen with our hands on that how this is working. So if I go into the code and details of everything, So let's go first of all. Let's go and we will discuss it there. So are we having time, Ragi Bhaiya, for this today?
Yeah, we have. It's still 10 minutes left, and you guys mind waiting 10 minutes extra? Anyone has any issue?
No issue. No.
Actually, I forgot to explain the IP datagram. So after this, I'll put it if possible.
So how will we proceed? We will explain the whole code today.
That's not an issue.
Okay.
Since you're
Okay. So what I need you to do is, so what is this? What is this? In Mosquito, as you have installed your Mosquito broker into your computer, so it is very fine. It is working. Try to do it in Ubuntu. This is very fast. As you have seen, I have also demonstrated that using in Windows, and it is kind of something lagging or something. There's a problem with the broker. So you can do it in Ubuntu. I will give you the steps and everything in the Discord afterwards. So if you have your Ubuntu and you can, you can always. So I will request everyone, please, for now, if we have finished the demo for this, so if you can disconnect with the little disconnect button on the top right corner. So yeah, Aditya disconnected. Thank you. Yeah, Dokania disconnected. Anubhav also disconnected. Okay, fine. So that's very much fine. So I'm ending this for now. Yeah, just a minute. Yeah, okay, let that run. Okay, everybody, for coding it into the Node MCU, so we need some libraries, right? We cannot code it directly into that part. So for that library, we need to open Arduino first, then go to Sketch, include libraries, then manage libraries. Let that open. Yeah. Okay, just I can turn off this now. Yeah, in this manage library, first you can filter that like writing pub sub client. Okay. If you go down a little bit, you can see this library or pub sub client by Nico Leary. Are you following or anybody among these three, are you having Node MCU right now with you?
Yes, sir. I have it.
No, Bhaiya.
Okay, not an issue. You can.
Banker you have over here, right?
Yes, sir.
I can see. Okay, you
Okay,
have
so
Node
we can.
MCU or ESP32, right?
No, I have Node MCU 8266.
Okay, fine. So you can go to your Arduino IDE and go to your Sketch, then include libraries and install this. Everybody can, for sake of programming and learning how to do this, we can. Just install it, clicking the install. As I've already installed, it will not be shown installing. So you can install here. Okay. So now after installing, close it.